continue with our evening and with the awards. But I wanted to introduce to you Larry Berliner. He's received his BS in chemistry from UCLA, his PhD in physical chemistry from Stanford. Then he did a postdoc at Oxford in biophysics, and then another postdoc at Stanford University in biochemistry. So I wanted you students to see how many different places he went to, right? And how many different types of areas of chemistry he worked on. So I purposely wanted you to know that. Then he started as an assistant professor at Ohio University, and he rose through the ranks until he became a professor there. Then we were lucky in 2001, he moved to Colorado, and he became the chair of the Department of Chemistry and Biochemistry at DU, where he still teaches and does research. Dr. Berliner is one of the pioneers in protein structure and molecular diagnostic techniques, and he continues that work at the toxicology graduate program at the University of Colorado Health Sciences Center. He is also the editor of Cell Biochemistry and Biophysics. See how that tied back to those degrees that he got, right? And guess what? In his spare time, he does work for the American Chemical Society, such as giving our talk here this evening. So let's give a big, warm welcome to Larry Berliner.
I need this stool. Okay, I just need this stool. If we can take this off of here. So I'm
glad we ran out of space this evening. You know, we're running out of space everywhere, so that's a good thing to have. It's always a good sign.
Good thing. I need to give a couple of credits. First off, we have a wonderful group that is streaming this whole thing online. And George Stickler and Ben Melnick and Angie Stickler are running the show. The information is on your table. They do weddings, events, bar mitzvahs, things like that. I highly recommend them. Secondly, the cartoons that you saw streaming earlier is from a recent book by Sidney Harris. It's called Eureka, Details to Follow, Cartoons in Chemistry. He has put cartoons in lots of publications, Scientific American, Physics Today, so on and so forth. He lives in New Haven, Connecticut. They gave us permission to reproduce this book and such. So if you like some of these things, I highly recommend this book. There's going to be a little bit of his material in my talk as well. So the question is, where is Joseph Gall? Okay, and I arranged for him to talk at this meeting, and he very recently suddenly was unable to come, and I sort of took over, and my talk will be sort of a combination of his and things that I'm interested in as well. And I have made a slight modification of this title, Heroes and Heroines of Chemistry. And in terms of who are the heroes of chemistry, I think this is really the prerogative of the speaker. And I'll tell you who mine are that I'm going to be telling you about. Some are Joe's and some are of mine. Alfred Nobel. We've all heard of the Nobel Prize. We'll hear more about that. And he was also a chemist. These are some of my favorites. Again, I should mention, we have ACS members, chemistry teachers, and chemistry students, but we also have family members here. So I'm going to really try to be an after-dinner speaker and entertain you and not do too much sort of fundamental chemistry. Okay. My next hero is Avogadro, which I think the students are going to know about. Mendeleev, who we're going to talk a lot about. My real heroine is Marie Curie. I'm going to talk a bit about her. Fritz Haber, we'll hear a bit about. And then my last and personal one, who's a real role model for me, is Linus Pauling. And we're going to do all of this in 30 minutes, including cartoons and so on and so forth. So we'll sort of get going with all of this. And I'm going to jump a little around in history. And the reason is because I want to talk about Alfred Nobel first. And this is just for all of us in this room. You know, what's a 9-letter word for biotech? It's chemistry. American Chemical Society is about 170,000 members worldwide. We are the largest professional science organization. We have lots of foreign members now. We have student members. And so we feel we're important. One of the logos was chemistry is the central science. And nowadays it's the chemistry of life, just to give you an idea of where things are going. So I want to talk about Alfred Nobel. He was born in Stockholm in 1833. And this man was a true genius. I mean, and just look at one of his quotes. I need to tell you that when he died, which was before 1900, he had over 300 patents. It's kind of tough to do, you'd think, with not having the equipment and such that we had nowadays. He spoke 5 languages fluently. He was a Swedish chemist. He's an inventor of dynamite, which we'll hear about, an engineer, an armaments manufacturer, a businessman. But he was also interested in literature, in biology, in medicine, and I might talk a little bit about peace, but we're going to spend most of the time talking about the scientific aspects. So a little bit of his history. He was quite ill as a young man. People think he may have had a form of epilepsy. His mother cared for him for several years. He was really bedridden for quite a while. And as I said, he knew 5 languages. So just for the fun of it, he'd take an American author and just translate whatever they wrote into 1 or 2 other languages. Just really a genius. He actually wrote some literature as well. His father had a business, and it was really what we call civil engineering. Helping to sort of blast rock apart so you can build highways or bridges or so on and so forth. And as I said, Alfred was interested in several subjects. His father was particularly not interested in his interest in literature. He said, no, you're going to be a scientist or you're going to be an engineer. So he went to Paris and worked in the private laboratory of Professor Pelouse. And in this lab was an Italian chemist named Asconio Sobrero. He invented nitroglycerin, okay, which is, as we know, is a highly explosive liquid. And it was really considered to be too dangerous to sort of be of practical use. And I'll sort of reflect on the medical aspects of this. Several people have relatives or maybe even suffer from angina where the heart muscle gets really tight and there's a lot of pain, and it turns out nitroglycerin relieves that pain. Okay, has something to do with a whole other aspect of metabolism and biology, has to do with nitric oxide. But I might mention, or maybe you can ask me a question afterwards, what Alfred thought of nitroglycerin. So The father actually had gone off to Russia to sell things to the Tsar because we had the Crimean War, the British were coming in, to the port of Leningrad, and so the father was, selling landmines. It was a good way to stop the British ships. Father was not the best businessman. Came back to Sweden, and both he and Alfred became very interested in nitroglycerin and how they could use this for commercial aspects. What I have to tell you is, and don't do this at home, actually don't ever do this experiment. Take glycerin, by the way, that it comes from lard. If you boil animal fat, you'll get glycerin and you'll get fatty acids, and nitric acid, and you just cook them together and you heat it up to a certain temperature, don't go beyond it, and you will form nitroglycerin. Well, in fact, they were doing this, and his father was sort of overseeing things and watching the temperature, and they very sadly had an explosion where his younger brother, Emil, was killed, died, and another sort of worker. Perhaps Alfred held this against his father. And then you're doing these experiments, and what happens occasionally when you're doing experiments? That happens, and the city of Stockholm was not very happy about that, so no more nitroglycerin work in Stockholm. And so they went out to Lake Mälaren, where they did some more of these experiments, and we just sort of heard what happened. Normally I have this actually, George, at about 1.5 times the volume just to startle people. Do you think I'm going to do another one? Yeah. You may be right. In 1864, they could mass produce nitroglycerin. But you can imagine it's a liquid in a little bottle. How do you ship this around the world? And if I had a bottle of it here and dropped it on the floor, I don't think there's enough time to run like mad. So they needed to have it in a form where they could handle it, and they tried things like sawdust and charcoal and so on and so forth. And Alfred found that mixing it with something called kieselguhr, it's diatomaceous earth that used to be used in swimming pool filters and so on and so forth. They could make a paste, then you could make it into rods, and then if you were going to blow up a mountain, and there is a little challenge right here on Interstate 70 about how you get to the other side. You could put these rods in there and either light a match and run like hell, or actually we can, do this in a little bit better way now. And by the way, that blasting still goes on Interstate 70. He had patented a blasting cap for this, and he called it dynamite. Okay. And it worked. So to make a long story short, Nobel was super wealthy. They had factories all over the world. And guess what else you can use explosives for? War. That's the best business. In fact, he didn't like being called a warmonger, even though he was sort of macho about this. But they had, the entire business. Somewhere in 1895, he signed his will and testament. He spent a lot of time living in Paris and then also in San Remo, Italy. And on December 10th, he died. And in his last will and testament, he said much of his fortune was to be used for people who have done their best work for humanity in physics, chemistry, physiology or medicine, literature, and peace. And we know that these 5 Nobel Prizes still exist till today. It's probably one of the few really popular, highly respected things in American culture. The rest of it is Madonna and so on and so forth. If any of you have ever been in Scandinavia in the second week of December and you switch on the television, you will see the Nobel Prize ceremonies, a dinner like this being videotaped. And the Nobel Prizes are awarded every year on December 10th, the day that he died. Okay. Turned out it took 5 years from when he died to establish the Nobel Prizes. Lots of problems, okay? He had relatives. He'd never married, but his brothers and such, they wanted some of the money. Convincing the Royal Academy in Sweden to give out these awards was difficult. They said, yeah, we don't like awards and so on and so forth. Even took the King of Sweden to convince them to do it. So it wasn't until 1901 that the first Nobel Prizes were awarded. And I happen just to have some photos of the ceremonies most recently. So the first four, this is in Stockholm, and the fifth prize is the Peace Prize, which is awarded by the King of Norway, and the committee that decides on it is the committee of the Norwegian Parliament. And Nobel had insight, foresight, whatever it was. He didn't like the whole militaristic attitude of the Swedes. And Norway at the time, I think, was the first nation to sign a peace document. So this, to this day, still occurs in Oslo. And I just sort of like to put this slide up here. It just sort of tells us how long it takes in science to do things, okay? And this poor guy's a little bit frustrated. So let's get to some history of chemistry. And again, I'll keep the specifics really minimal. And I'm going to go to 400 BC because this Greek philosopher, Democritus, had a theory already about matter, and he really came up with the concept of the atom, atomos, okay? You know, an indivisible particle. As we know nowadays, you can actually break it apart, but that took a lot longer for that to happen. So 400 BC, okay? And when we talk about the history of chemistry, we have to really come in to physics as well. And I stuck in someone that I think was really important at that time. And this is Archimedes, who was a Greek mathematician who noticed that something we all noticed, when you get into the bathtub, there's something called buoyancy, okay? You displace an amount of water, okay? And depending on your density and the density of the water, you may go to the bottom or sort of float on it, by the way. Try this experiment with classic Coke and Diet Coke, and you'll be really surprised. The Diet Coke floats at the top, and the classic Coke goes all the way down to the bottom. Guess what gives it all that density? So I think this guy's important. And this, by the way, this sculpture is actually in Israel. It's not sitting in Greece. So let's talk about the chemical elements. We've got 100 or so now, up to 118. And these are the substances, right? They come from atoms. They can't be chemically interconverted, and they can react with you. And we have to use the word elements because that's how sort of the way we classify all of our chemicals. And they really can't be broken down into smaller parts. Again, radioactive substances notwithstanding. That's something that really comes later in history. So what about starting to classify these things? So I sort of defined elements, and this is John Dalton and the atomic theory. British scientists, we're going to find a lot of the chemists at this time, British, French, Italian, and German principally, certainly before the 1900s. And people were observing similarities with some of these chemical elements. You know, this one and this one and this one seem to be the same. Maybe they smell the same. They have some reactive properties, so on and so forth. So they're already being able to sort of, just from this observation, classify these into groups. And lots of people were coming up with ideas or tables of ways of classifying these elements. And I think a lot of the chemistry students, you know about all of Dalton's laws, combining things, so on and so forth. He's a great scientist. He was unfortunately off on one or two little things. I think we're all entitled for that. But actually, all of these proposals for how you classify were never really accepted by the scientific community. Okay? So that was going on. And then a really important man, Lorenzo Romano Amadeo Carlo Avogadro di Querina e di Cerreto. What a wonderful name for a chemist. That's classy. And he was the Count of Querina and Cerreto. And he actually studied church law, and then he studied math and physics extensively. And this is a really important law. Lots of the chemical elements exist as gases, and he was studying them. And that was equal volumes of all gases at the same temperature and pressure have the same number of molecules. By the way, Dalton really wasn't into this thing called molecules. I mean, it was really Avogadro who came up with this. And just look at him, man. What an imposing character. He pointed out that atoms can form molecules, and that the natural elements, such as oxygen, hydrogen, nitrogen, chlorine, you know, these are gases, they exist as two atoms bound together, bonded together. And we would call these fancy word diatomic molecules made out of two atoms. So we have O2, H2, N2, and Cl2. And people that were doing experiments with gases, chemical reactions and such as Avogadro could figure this out. John Dalton was just a little off on this, okay? He thought water was HO, okay? And we had, by the way, we started to have weights for each of these atoms and molecules as well. So he was a little misguided, but still a great scientist. And it took a long time for Avogadro's observations to be accepted. He had support from other Italian scientists, but the other people were just really slow. So this kind of politics and provincialism exist, and for all we know, it still exists today. So a little bit of science, and this is for my chemistry students. Avogadro's number. And I did it with all the zeros. I thought it was going to fill up a full page, and it didn't. And this is what it's all about. If you take 22.4 liters of a gas, so that's, 22 liters of Coca-Cola volume, at 1 atmosphere pressure, 760 millimeters, and 0 degrees centigrade, you will get that number, if it's atoms, of atoms, if it's molecules, of molecules, and it's what we call the mole. And I always tell my general chemistry students, if you didn't learn anything else in chemistry, the mole, okay? That's probably one of the most important concepts we'll ever have in chemistry. And it doesn't matter what the gas is, and if it's made up of atoms and molecules, this holds. So he now knows he's in that volume, he's got the same number. He can weigh them and get their relative weights. He can follow chemical reactions. So this man was really phenomenal. Obviously deserved a Nobel Prize, but remember, Nobel Prize was not granted until 1901. And another chemist named Cannizzaro was providing a basis for figuring out the relative weights of these elements, which we call atomic weights. And again, it's Avogadro's law. We knew of about 60 elements by the middle of the 19th century. And one needed to kind of organize these in maybe some logical way that we can follow it. And who was the man who we really recognize as really doing it? Dmitri Mendeleev. He graduated from St. Petersburg Pedagogical Institute in 1855, studied in Europe and Germany for a few years, and finished his PhD in St. Petersburg, and was in the chemistry department at the University of St. Petersburg. I really love the lower photo of him. That's a real chemist. You know, the guy up above is a little too formal for me. But he had noticed that there was some relationship with these atoms. There seemed to be elements increasing their weight, and also, again, their properties. Lots of times they're chemical reactive properties. And he was writing a chemistry textbook when he was really sort of thinking about these things. And in 1869, he published this table of his periodic table where there might be some periodicity in the properties and the weights of the elements. This is a little bit hard to read. There are gaps here, but he predicted where elements would be found and discovered to fill those gaps. That's really, truly amazing. And these elements were discovered later, and he continually improved this table and really received worldwide scientific recognition. And this is the table that several of us see in our classrooms. Actually, this is the first university room I've been in where there's not a table hanging on the wall. And this is, you know, what we're generally using as the modern day periodic table. There are a lot of people who have different ideas, shapes, sizes. There's a committee right now of the International Union of Pure and Applied Chemistry, it's IUPAC, that's going to sit and deliberate and figure out if we come out with a new periodic table. It turns out, and this is again for our students, the order that these are in as we go from the left to the right in any row has to do with the electronic structure as we're adding protons and electrons to these. Where you see colors, they're families of elements that sort of behave in the same way. So I think some people have heard of lithium, sodium, potassium, maybe as a group, and certainly on the right, one left, fluorine, chlorine, bromine, iodine, they're what we call the halogens, and they have similar properties. And he basically could predict all of this. And, you know, they're families, right? So this is a periodic table that Sidney Harris came up with all of his family members, Ilya, Masha, Yakov, so on and so forth. I kind of like that. So it turns out this was 1869, and if I do my math right, we're 2019. This is 150 years since he presented, discovered, put together periodic table. So this is the International Year of Periodic Table of the Chemical Elements, designated by UNESCO. The American Chemical Society is obviously extremely interested in all of this as well. It's obviously spurred creativity that you can't believe that's over here on this table. And so, you know, we give a lot to Mendeleev. I don't know how I'm doing on time, but I have to get to one of my most favorite heroines of science, Marie Curie Sklodowska. She was born in Warsaw, and it wasn't Warsaw, Poland. For those of you who know world history, Poland was not a country for 100 years or so. It was occupied by other powers, and Warsaw was an area occupied by the Russians. You could not speak Polish. The Russian inspectors would come to the schools and make the children stand up and recite things in Russian, recite the names of all the Russian patriarchs, so on and so forth. Women were not allowed to go to university, certainly in that realm of things. Her mother died when she was 11 years old of tuberculosis, so she didn't really have that part of her family. And because the mother had tuberculosis, she always would stay away from the children. She was never really hugged or anything by her mother. What she overcame was amazing. And she ended up going to the Sorbonne and studying physics and mathematics, placing first and second place. Okay, in Paris, this is someone who was born and raised in Poland, first in her class, of course, in secondary school. And she was awarded a graduate position to undertake research towards a PhD in Paris. And let me tell you what her research project was about. What you see on your left is a Röntgen ray. So William Röntgen, a German scientist, had shown that you could get photographs on photographic paper by passing some rays from things such maybe as uranium or something like that. He called them X-rays. X means unknown. He didn't know what it was all about. And a French physicist, also in Paris, Henri Becquerel, had accidentally discovered if you uranium and thorium in particular, they emitted rays. A photographic plate got developed in the dark, okay, if it was near this. And again, to some degree, a bit mysterious to these people. I think these discoveries and observations are really important. So she studied this and their properties and concluded that the emission of these rays was an atomic property of the element, like uranium, built into the very structure of the atoms. And she invented the word, which I think slipped off the screen, radioactivity. So radioactivity is for her. She met a physicist named Pierre Curie, who, by the way, had invented the electrometer. Okay, it's a lot easier way to measure radiation than doing things with photographic plates. And she and Pierre joined her, set out to attempt to isolate, well, they thought what was in uranium ores. It turns out there's some in pitchblende, which is just a byproduct of mining. So they got several tons of pitchblende sent to them just for the shipping costs. They had to use a lot of their own money to set up a lab. And now I've goofed this up. Yeah, there's the lab. It was an old shed. And they spent several years taking this pitchblende, breaking it down to isolate pure substances. And what they came up with was radium chloride, and the other one she called polonium, named after her mother country. Okay, 2 elements in the periodic table. They're there as cupcakes as well. She was never able to get pure polonium because its half-life was only 138 days. She developed terrible arthritis, so did Pierre. The ends of her fingers were raw, etc. She died of a form of leukemia because these people didn't know, at the time what this stuff was all about. Nonetheless, she was helping out in the war effort, World War I, helping getting X-ray machines out into the field so they could diagnose a soldier who'd had an injury, so on and so forth. She was given 2 Nobel Prizes. Nobel Prize, the first one was in physics together with Pierre and Henri Becquerel. And this was really this work that she had done as part of her PhD project. And then one given to her solely in chemistry in 1911, and that was the discovery of the elements radium and polonium. I mean, this is just quite a feat. She comes and talks to my freshman seminar class once every fall, and if some of you would like to hear her, maybe I can arrange for that to happen. And I kind of like this cartoon as well, again by Sidney Harris. This is really a description of what went on in that laboratory. So really one of my real heroines. Now I'm going to tell you a story that involves several elements, and in particular nitrogen. 1900, the world population was 1.6 billion. It was predicted we're going to have mass starvation as the population of the Earth increases. And what's the problem? Nitrogen-containing fertilizers. It was guano that was brought in from Chile. That was fertilizer. There was no way that they could get enough of this to help the world's population. And nitrogen's really important for humans, so on and so forth. There's a lot of it around. We're breathing it right now. 78% nitrogen. So I guess all we have to do is react it and we'll get ammonia and we'll get fertilizer. Okay? And it's in our amino acids, our DNA, so on and so forth. And so it's in foods, but as I mentioned, the only fertilizer was guano. Okay? And who was the person that solved this? A German chemist named Fritz Haber. There he is. PhD from the University of Berlin. He began his university career in 1894. And the whole idea was to make this chemical reaction occur. And by the way, my chemistry students in here have to tell me afterwards if this is a balanced equation or not. Okay? We're not going to let you know. And I have to let you know that soybeans can do this with ease, and anaerobic bacteria can do this with ease. But us figuring out sort of how to do this in a quick and a commercial way was difficult. It was a challenging problem. It had to be done at very high temperatures. We're talking 1,000 degrees Fahrenheit, 200 atmospheres of pressure, and he could force this reaction to occur and go to the right. And he received Nobel Prize in chemistry in 1918 for this work. So we now had ammonia converted now into nitrogen N-containing fertilizer. This saved millions of lives of people, who really would have starved to death. So nowadays, about something over 150 million tons of ammonia is produced each year, very much for fertilizers. And in the next slide, I kind of think about, these poor organic food stores, and here you've got the fertilizer industry and the pesticide industry picketing them because for some reason people want to go eat organic foods. But anyhow, that's another Sidney Harris thing. So what else happened around this time period? World War I broke out early August 1914. And Germany had a problem. They had a limited number of explosive. Their stocks for explosives maybe would last a year, right? And we know Germany wants to prevail in this war, which was one of the biggest, worst, stupid disasters we've ever had on this planet, including what the Middle East is all about nowadays. It turns out explosives use compounds. You notice that word Ni, nitrates, right, from nitrogen. And ammonium nitrate is a really good explosive. I think this is what was used in the Oklahoma City explosion of that building. There are other ones, trinitrotoluene. We talked about nitroglycerin. So that's what it can be used for. Civilian use is wonderful. Tunnels, bridges, roads, etc. What's a military use? Death and destruction. But after his development of getting ammonia, there were processes to convert ammonia to nitrates. There's some really big, successful German chemical industry working in all of this. And it really provided unlimited explosives, obviously for the Germans as well. The war bogged down, trench warfare, not a lot of success, and so the Germans got into chemical warfare. And guess who was a real mover in all of this? Fritz Haber. So Fritz Haber, who saved all these lives for people starving, was a whole strong proponent of chemical warfare. I think people have heard of the Geneva Convention after World War I that said we will not use chemical warfare in wars. He was so interested, he just kept on doing this, okay? And in fact, he died before World War II really got on, but he was also the father of the Zyklon B that was used in the gas chambers in Germany. So we have a hero chemistry, and we have an anti-hero. And his particular story really raises difficult sort of moral and ethical questions. Anyone's interested in this, there's a book called Mastermind, if you really want to read his history. You'll need a strong stomach for it, but he was a very interesting character. And we're getting to the end, to my other real hero. It's Linus Pauling. I think I'm still right on this. The only person to have been awarded 2 unshared Nobel Prizes. He wrote a book called The Nature of the Chemical Bond, and you can see the copyright dates in the right. I have that book on my shelf. Most of my colleagues do, and I think we'll tell you we can still open that book up, and it's timely to a very great degree. The citation for his Nobel Prize, research into the nature of the chemical bond and its application elucidation of the structure of complex substances. He worked on biological things. He was really the one that showed us the structure of the alpha helix in proteins. He was into anesthesia. He probably only went wrong on one thing, and I think everybody's entitled to do this, which was vitamin C. Okay, he just had it wrong. I mean, I still take a few grams of vitamin C orally when I'm not feeling well, but it turns out most of it just gets excreted, that you have to use vitamin C IV to really get things going. But in the other aspect in which he was the hero, he received the Nobel Peace Prize in 1962. And again, the citation, his work against the use and proliferation of nuclear weapons. And this is the Cold War. Do you think the US government was happy with him when we have Atomic Energy Commission and we're really trying to push atomic energy and of course, atomic weapons? He was put under FBI surveillance. His grants were canceled. They would refuse him a passport. He was vilified by the press. So I think a really amazing, courageous person of that era. And so my last slide sort of relates to all the high school awardees in this room. You are the future of science and chemistry, okay? The gray hairs and no hair sitting in here, they're not going to be contributing that much longer. And I kind of wonder if you were inspired as a young child.
There's oxygen so you can breathe. Boiling fire, plenty tea. Neon to light up the sides. Sodium for salty ducks. Magnesium. Aluminum. Silicon. Phosphorus. Then sulfur. Chlorine. And argon. Potassium. And calcium so you'll go strong. Scandium. Titanium. Vanadium, chromium.
So I think I'll stop it at that. We can play more if you'd like. And thank you for your attention, and I can't wait to hear of all the high school awardees. Okay, thank you. I'm going to sit down for a little bit.
All right, we have arrived at the time of the evening that you have been waiting for. So we're going to start doing the awards, but I would like to point out that Cork Hayden, our photographer, is going to do some pictures. So what Cork is going to do is he's going to take an individual picture this year of each of the students as you come up to get your awards. So if you could please just, be patient with that so that we can make sure that we get a picture of each of the students. We want to make sure that you're all, recognized for all of your hard work, all of your teachers' hard work, all of your parents' hard work, and you still got a lot more work and chemistry to go, as you saw from all the things that I told you about Dr. Berliner on all the education that he had. So you have a ways to go, but you've got a good start. So I'm going to start by having Sue Shelby come up, and what she's going to do is she's going to give our ACS Chemistry of the Teacher of the Year Award. So Sue, you are. You didn't know that? Oh, okay. I can do it if who is doing the Teacher of the Year? I can do it. I can do it. I've got it, guys. I've got it covered, okay? This year, we are giving the ACS Chemistry Teacher of the Year Award to David Ferguson. So, David, could you please come forward? Okay.
It was the volunteer one we were looking for. Okay.
Do you want to say something
Sure.
about him? Okay, Eleanor has some things to say, and then I could add some things too, but we'll let Eleanor get started.
Okay. Each year we give one award to a high school chemistry teacher, and a lot of times we try to catch them about the time they're retiring. And it just turns out that I didn't know David was retiring, but a few of us got together and decided that he was the one. And then when I talked to him, he says, well, by the way, I'm retiring. I said, well, I guess we caught you at the right time. But anyway, he worked in aerospace for a while. He originally graduated from the U.S. Air Force Academy, and then he realized he really liked kids and he liked teaching. And if you saw the recommendation letter that his principal wrote, it was totally amazing. And one of the things that kind of sticks in my mind for us teachers who have taught AP Chemistry, he has a student who got a 1 on the AP exam and is now finishing his PhD in chemistry. So just because you don't get a 5 on your exam doesn't mean that you can't be successful in chemistry. So I think that's really good. If you look him up on the Rock Canyon website, he's got a tie-dye, beautiful tie-dye shirt on. And I think he learned to tie-dye from me, right? So anyway, in 1989, I started doing tie-dye, and I taught about 500 different teachers, and David was in one of my classes. So congratulations, David. Wow, cool.
Yes.
And Court wants to get a picture of you.
Yeah.
Congratulations.
Larry. What happened to Larry? Okay, great. You want to bring Kathy up? Shy? Okay.
Okay, at this time, we'd like to have Margaret Asavirtham come forward. And for you chemistry teachers who have taught for a while, I hope that you have had an opportunity to go to the CU Boulder Day. It was usually in October between homecoming and something else going on. And Margaret, for over 30 years, organized this day. And it was always a day where teachers could come and learn new things. And Margaret was always coming up with new things other than lecture in the classroom. She was often using clickers and all kinds of things that, of course, they use now. But anyway, one of the things the teachers always enjoyed, we had a wonderful lunch, and they served wine. I mean, high school teachers being able to go to a class and get wine, we loved it. She received her first degrees in India, and then she came to Kansas, I believe, and she has been at CU Boulder for over 30 years. She's now retired. She's working on programs for her grandchildren who live in San Diego. So welcome, and congratulations. go get our picture taken.
I do want to say that being at CU Boulder and hosting the High School Teachers Conference was one of the best things of my career at CU Boulder. But a lot of that credit goes to Eleanor Groh, Jeanette Carpenter, Marty McGuire, Rosimus. They were just so supportive. And she still continues to actually send out all the information to the teachers. So it's never one person who does this. It takes a group of people. And Anne McWilliams is the other person at CU Boulder, who is the Mother Superior of General Chemistry. So thanks to everybody who made this
Let's go
happen.
here and get a picture.
And we have a set.
Everybody say money.
I'm going to introduce our former chair of ACS, Marion O'Connor, who is going to present the award for the National ACS Volunteer.
So if I could have Dr. Connie Gable come up and join me, please. It's my pleasure to introduce, I am not good at public speaking, so excuse me. Connie Gable, she is this year's recipient of the 2019 Local Section Outreach Volunteer of the Year Award on behalf of the National American Chemical Society and the Colorado Local Section of the ACS that nominated her. Wow. So the nomination letter could only have 100 words. I struggled, Sue struggled, Larry struggled to get her nomination to 100 words. Her nomination later stated, Connie Gable has been the key outreach member of the Colorado local section, bringing ACS activities to the broader community for a decade. She led the National Chemistry Week for 12 years and has been coordinator of Chemists Celebrate Earth Week for 6 years. Connie hosts the annual awards banquet outreach volunteer for outstanding high school students. She received the Colorado Local Section Volunteer Award and the Ann McNally Rocky Mountain Region Award for Volunteer Service, 2017. Connie has been the program chair in 2002 and the leader in 2017 for the Rocky Mountain Regional Meetings and planning for the ACS convention that was held in 2015 in Denver. In addition to all that, many of you students may have interacted with Connie. She volunteers regularly to judge poster presentations at local, regional, and national meetings and the Colorado State University Science and Engineering Fair every April-ish. April 11th this year it was. So in addition, we know from Connie's presentation at executive board meetings how many hours she spends every year contacting people for the Earth Week celebration, sending out packets of activities, and she's done this for 6 years, and she did the same with National Chemistry Week for 12 years also. Connie's hours of work alone for the activities for the regional and national meeting in Denver probably are equivalent to a full-time employee, an FTE as we call it. And that equates to 32 to 40 hours a week on top of her regular schedule of teaching at that time. So, Connie, we thank you for all your years of volunteering for the local, regional, and national ACS. And I have your little goodie bag.
Oh, wow.
Here's your letter
This is
from
amazing.
National.
Wow. Thank you.
And here's your plaque.
A plaque.
It's
Wow.
very nice.
It is very nice.
I was just delighted when I saw it.
It is a very nice plaque. I've not seen one like that before. And I've been with ACS for a while now. Wow.
So if you'd like to say a few words.
Well, you have figured out that I've learned how to do lots of juggling,
and, do things in different situations and so forth. But I wanted you to know that this year we had a big Earth Day celebration at the Garden of the Gods, and so we had some of our people there participating, right? And then Richard and I have been doing student grants today. We've been rating checks, so we send lots and lots of people to all the different meetings and so forth. So it takes many, many, many people, is what I'm pointing out, to be able to do all of these things. I've had a lot of help from Sue and Marion and Eleanor and Greta and all these, and Margaret. I've worked with Margaret as well. So a lot of people in this room have helped accomplish all these things. So thank you so very much.
At this time, I'd like, yeah.
Wants a picture, I think.
Yeah, go get your picture. I'd like to have David Ferguson and Emily Haynes and Margaret Asaviratham come back up.
Yes, forgot about the picture for myself.
Each year when we find out that teachers are retiring, we like to give them a little certificate. They can hang it on the wall or throw it in the garbage or whatever they want to do. So come on up, Emily. And we have another person that's not here tonight that is also retiring. Let me get my little list there. Emily is at 27 years, and I know she's not going to retire because she's going to start teaching here. So congratulations. And we have David Ferguson. Now, he worked in aerospace for about 20 years, but he's been teaching high school chemistry for 27 years, so congratulations. And we have Margaret, and Margaret, I have down 32 years, so if you want to go over there, they'll get another picture of you. Thank you very much.
You gotta have, you have to be. Whiteboard makes a terrible back.
Okay, at this time, Greta is going to be announcing the teacher's name and the awardee. So would they both come up, and we want them to stand over there, and Cork will get the picture of the teacher presenting the medallion to the student. Okay?
So I want to welcome all the parents and grandparents and siblings and other family members who are here today. This is a very exciting day for all the students, and it's with great honor that I am here to announce your names, and let's get going. So our first teacher is Chris Powers from Devlin High School, and his student is Cole Christie. Great. Can I go? Yeah? Can I go? I should go. Let me go. Okay. Our next teacher is not here. It's Mary Bartholomew, but her student is here. Representing Regis Boys, Eric Lee. Could you please come up?
Sandy Robertson, come up.
Yeah, no, I'm gonna, yeah, I got it. Along with Eric Lee, we have Sandy Robertson, who is also a Regis Boys chemistry teacher, and her student is Ryan Oceanero, if he could come up also. Our next teacher is Lisa Bradley, and she's from Denver School of the Arts, and her student is Sarah Hofer. Our next teacher is Laura Duncan from Boulder High School, and her student is George Matsumara. Our next teacher is Pam Fry from Estes Park High School, and her student is Sage Shumate. And our special honoree for the evening is Dave Ferguson from Rock Canyon High School, and his student is Wen Tao Zhang. Also representing Rock Canyon High School is Carrie Hinton, and her student is Gabrielle Leclerc. Okay. Great. Our next teacher is Stefan Graham from Arupe Jesuit, and his student is Daniel Brandt. His second student is Jimena Gonzalez. So. I did, yes. Our next teacher is Jo Tawari from Green Mountain High School, and her student is Luke Logan. Our next teacher is not here today. It's Brian Haytack from Arapahoe High School, and his student is Taylor LaValle. Our next teacher is Corey Bruckner from Heritage High School, and his student is Catherine French. Our next teacher is Maxine Morris from Jefferson Academy, and this student is Sibi Raja. Our next teacher is Bruce Randall, and he represents Mountain Range High School, and his student is Mel White. Also from Mountain Range is Dave McCall, and his student is Anna Kane. Okay. she's not here. Okay, okay. Thanks for being here. Okay. Okay, great. Daniel Price is the teacher from Columbine High School, and he has 2 students, Alex Hoffman and Janelle Gilland. Honors. Okay, yeah.
But I'll present it.
Okay, great, perfect, great. Okay. Okay. That's nice. Okay. Okay. Our next teacher is Derek Stogg, and he's from Castleview High School. He has 2 students representing Castleview High School, Heather Siomsky, and Annalyn Carlisle. Okay. The next teacher is Derek Manus from Pomona High School, and his student is Megan McGarvey. Excuse me. Also from Pomona High School is Matt Hallstrom, and his student is Nick Price. Next teacher is Carl Hansen from Windsor High School, and his student is Ashlyn Brown.
Carrie Hansen.
Carrie Hansen, sorry. Sorry, Carrie. Her second student is Addison Moyer. Okay. Great. Our next teacher is Emily Haynes from Centaurus High School, and her student is Megan Finnegan. Yes, you can.
Okay. Greta Sharp, Hannah Siegel. There you go. And Hayden Jones. Give that to Greta then. Last year, we started the program where you could nominate an AP student and a regular chemistry student. So that's why some schools have 2 students and some schools just have 1 student. So it was up to them. Okay, Greta? Anything else to say? Because I have something to say.
Yes.
Oh, closed.
Oh, my goodness.
Okay. Say something like money.
Where is the money? Greta, I want you to stay up here for a minute. I found something that I thought Greta would really enjoy, and it's the chemistry clock, but it says Mrs. Sharp's classroom on it. So there you go.
I just want to end by saying thank you to all the wonderful parents. Without you, we wouldn't have these wonderful students. And so let's give a big applause to the parents. Thank you very much, and have a good evening. Thanks.
You can choose anything on that table to take home. And then we also want to make sure that you get one of our cupcakes. We brought in some separate napkins there, and there are 120 cupcakes there, so I think between the gluten-free that can't eat it and so forth, there's probably one for everybody. So not just the students should take one. We don't want to take them home, so please, everybody, take one. And I would like to, at this time, thank the ACS for their support of this program all these years. Okay, so we're going to call some numbers now, and we want to do this fairly quickly because I know some of you have long drives home. Does anybody else have anything else? Want to thank the parents for taking their time, taking the teachers to take their time, and we also do send out about 40 medallions around the state to the teachers who can't drive in here. For instance, we usually have Pam Fry from Estes Park. She here? Yeah, she's probably driven the farthest tonight, but we usually get people who do drive a ways and make the effort. But you know, if you're in Durango, you're probably not going to drive in for the night. So anyway, I'm just going to call some numbers, some names of students. Ann Kai from Mountain Range, come on up and get your prize. It's C-A-I, is that spelled correctly? Where is she? Is she coming?
Just keep going.
Okay, I just need to. Okay, how about Alex Hoffman? That thing is not, sounds like there's some feedback. Don't be so close. Okay. Taylor LaValle. Luke Logan. Take one prize, whatever you, one each.
You get one.
Yeah. Daniel Brent. Gabrielle Clutter. Janelle Gilliland. Heather Slomsky. Hayden Jones. Sage Shoemate. George Matsumara. Cole Christie. Eric Lee. Ryan Ochenero. Nick Price. Ashton Brown. Addison Moyer. Megan Finnegan. Hannah Siegel. Annalyn Carlisle. Mai White. Catherine French. Now these are the names. Okay, Sarah Hofer. This one I'm not sure about, but I think it's Wento Shuang. Sheeman Gonzalez. Megan McGarvey. Did we get everyone? Is there anyone that did not get a prize if you were an awardee tonight? Okay, anything else? Connie, you want to say goodbye or anything else?
Aren't we doing the group photo?
Yes, that's
We're doing the group photos. So all of you award winners, remember that our photographer, Cork Hayden, will be taking a picture of all of you together as a group. And we really appreciate your patience this evening. It's been a great evening, and we need to thank once again all of those awardees for all their hard work. And don't forget the cupcakes. These teachers are telling me they don't want to take them home. So please remember the cupcakes.
I want to thank Mary Bartholomew and Greta and Marty and Jeanette for the periodic table Construction.
Too close.